Number 4 in your classwork for sequences, we want to find the rule for this sequence. So we have a sequence denoted d of n, and it's given by these 3 points here on the graph. And so if we connect these points, we can see that they all lie in a straight line. They're collinear. So we can actually make a function for these 3 points that would make them graph on the same line. So we have our slope given from the change in y over change in x between 2 points. So that can be this point here. That would be 2 minus this point, negative 1 over 5 minus 4, which is 3 over 1, which is a slope of 3. So if we were going to find an equation of the line here, we would say that y minus y naught is equal to 3 times x minus x naught, where we plug in one of these points for y naught. So let's say we use this point 2 and 3x minus 5. Now, in order to find our constant, we multiply this out, 3x minus 15, then we add the 2 to both sides, add the 2. So we have y is equal to 3x minus 13. And so even though this is an equation on the line, it also is the same as our rule for this sequence. 3, now instead of x, we're using n, because we're using only the natural numbers, minus 13. And we can see if we plug in, for example, 3 into this sequence, so we get 3 times 3, which is 9, minus 13 is negative 4, which comes out to this point here, 3 common negative 4. And the same is true for the other 2 points. So we know that this is the correct rule for this sequence. So now we can plug in negative 10 for d of n and solve for n. So 3n minus 13. Adding 13 to both sides, that's 3 equals 3n. So n is equal to 1 for this case. So this is part A. This is part B, n equals 1. And the value of d of 6 is when we plug in 6 for n. So we plug in 3 times 6 minus 13. That's equal to 18 minus 13, which is 5.